Guys, today we're going to do 3 logarithmic functions and their graphs, and our objectives are to learn about logarithmic functions and their graphs. So earlier we have learned about inverse functions, and we learned that if a function passes the horizontal line test, then its inverse will also be a function. Well, today we're going to learn about the inverses of exponential functions. So the inverse of an exponential function is going to be called the logarithmic function with base b. So this is written log little b, and we say log base b, parentheses x, close parentheses. So it's log base b of x. Or we could say log base b of x without the parentheses. So these two functions, exponential and logarithmic functions, can be changed between forms. So we have the logarithmic form of log base b of x is equal to y, and we have the exponential form, which is b to the y power is equal to x. So if you interchange those variables b, x, and y, we are then going to be able to change between logarithmic and exponential form. We can also use this to then evaluate simple logarithms when we put it into an understanding of an exponent. So this is a little circle that we form in order to go from log form to exponential form. We start at our base b and we go around the circle. So we would say b to the power of whatever y is, and we keep going around, equals x. And that's how we get the b to the power of y is equal to x. So now let's try it with some numbers. 2 to the power of 3 equals x. Equals 8, I'm sorry. So 2 to the power of 3 equals 8, which is true. 3 to the 1/2 power is equal to the square root of 3. 5 to the -1/2 equals 1/25, or 1/25. So as we can see, going around the circle brings us into exponential form. 4 to the 0 power is equal to 1. And 7 to the 1st power is equal to 7. So if you draw out the circle around, you should very easily be able to translate from exponential to logarithmic. I'm sorry, from logarithmic to exponential. So this is from log, and we're going to exponential. Now we have some basic properties of logs. Keep in mind the rules that we just talked about. So log base b of x is equal to y, and b to the y power is equal to x. There are other ways that we could try to remember this. Log base b of x is equal to y. I also write log base b of a is equal to e. This may get a little confusing with the e, but the e stands for the exponent, b is your base, and a is your answer. So when we're going into exponential form, you can see that the b would go where the base is. Here is our exponent, and a was our answer, what it's equal to. So our properties: log base b of 1 is equal to 0. So the base to the 0 power is equal to 1, because b to the 0 power is 1, because anything to the 0 power is 1. Then log base b of b equals 1, so b to the first power equals b, which makes sense because b to the first power is itself. B to the y power is equal to b to the y power. And then b to the exponent of log base b of x is equal to x. And the reason, because exponents undo logs. So then we have the log base b of x is equal to the log base b of x. Just some examples. Log base 2 of 8 is equal to log base 2 of 2 to the third power. And if we want to figure out what this is equal to, we have to figure out that it's 3. We could have also looked at that it was the log base 2 of 8 is equal to what power? So 2 to what power is equal to 8? 2 to the third power is equal to 8. Same thing here with log base 3 of the square root of 3. So our exponent needs to be 1/2. And 6 to the log base 6 of 11 is equal to 11. If we were to graph f of x is equal to 2 to the x power and the inverse, or log base 2 of x, and look at our tables, we see this relationship. So we see that our x values and our y values have switched, which means we have reflected over the line y is equal to x, which means that these two relationships are inverses. These are also the graphs, and as we can tell, they have been reflected over the line y is equal to x. Now if we say there is a common logarithm, that means we have base 10. So we can have any base we want in a logarithm, but if there is no base, it is base 10. So that means we wouldn't have a subscript here. We just write log of x. Y is equal to log of x if and only if 10 to the y power is equal to x. So this is just saying the exponential part of it. And then we have properties of common logs. So log of 1, which means base 10. 10 to the 0 power is 1. Makes sense. 10 to the first power is 10. 10 to the y power is 10 to the y power. And now we have 10 to the log of x power is equal to x, because this is technically 10 as well, which will then cancel, and we'll be left with log of x and log of x. I'm going to solve 2 of these, and then you guys solve the next 2. So I know that I'm in log form, and I need to find x, which means 4 to what power equals 4? 4 to the first power equals 4, so x equals 1. 6 to what power equals 1? Which means 6 to the 0 power, so x equals 1. You guys try 3 and 4, and we are done.